Okay, if you are a science student, you are in secondary school, senior secondary school, or you want to prepare for WAEC, or you want to prepare for JAMB. Now let's talk about physics. Under physics, we'll be talking about motion. Motion. Now, what is motion? Motion is the change in position of an object. The change in position of an object. Example is like a moving car. When a car moves from point A to point B, you will say the car has changed position. So that is motion. Then under motion, we'll be talking about rest. Rest. Now, rest. Rest means when there is no change in position. When there is no change in position, when there is no change in position, the object is in a particular place, there is no change. For example, a car that is parked in a particular place, or you can say a parked car. So you can say that object, that car is in a rest position, it's not in motion. Do you understand? Under motion, we'll be talking about some important terms that you have to know. We'll be talking about some important terms that you need to know under motion. The first one is distance. Distance. Now, what is distance? Distance is the total distance covered by an object. When an object moves from point A to point B, the total distance covered by that object is what we call distance. And also, distance is a scalar quantity. I know some of you will be asking me, what is a scalar quantity? You should know this by now. As a physics student, a scalar quantity is a quantity that has magnitude but no direction. A scalar quantity is a quantity that has magnitude but no direction. So distance is the total distance covered by an object. Another one is displacement. Displacement under motion. Now, when we're talking about displacement, displacement is like a straight line distance from the starting point to the end point with direction. When you have a straight line distance like this, you understand, from the starting point to the end point, you understand, with a direction. So that's what we call it, displacement. This displacement is a vector quantity. It is a vector quantity. And what is a vector quantity? A vector quantities are quantities that has magnitude and direction. So that's just the difference. Scalar quantity has no magnitude, has magnitude but no direction. But a vector quantity has what? Magnitude and direction. So the difference between distance and displacement is that distance is what? A scalar quantity, while vector is what? While displacement is a vector quantity. Now let's move on to speed. Speed. What is a speed? A speed is how fast an object moves. You understand? How fast an object moves in no direction. Speed can be in any direction. So when an object moves, you understand, it moves in no direction. You can say, it's the object undergoes what we call speed. And speed is a scalar quantity. Speed is a scalar quantity. Let's move on to velocity. Velocity is the rate of change of speed in a particular direction. Velocity is the rate of change of speed in a particular direction. Velocity is a vector quantity. Do you understand? It's a vector quantity. By now, you should understand what a vector quantity is. Now, let's move on to acceleration. Acceleration. What is acceleration? Acceleration is the change of velocity with time. Is the rate of change of velocity with time. Understand that acceleration is a vector quantity. Acceleration is a vector quantity. When you say acceleration, example of what we call acceleration is a car that is speeding up. When a car is moving at a particular speed, speeding up, you understand? So you can say that the speed is changing. So you can say that car is what? Accelerating. You understand? That's a car speeding up. That's example of acceleration. Now let's talk about deceleration. Deceleration. Deceleration is what we call negative acceleration. Negative acceleration. Now, example of negative acceleration, a car is a car that is slowing down. When a car is slowing down, you can say the car is what? Decelerating, right? So that is it. Now let's talk about types of motion. Under motion, we have 4 different types of motion. Let's talk about translational motion. Translational motion is like moving from one point to another. movement from one point, or moving from one point to another, like a car now that is moving forward. You can say that car is undergoing translational motion. When a car just moves forward, it's moving from one point to another. The car is moving forward. That means the car is undergoing translational motion. Another one is rotational motion. Rotational motion, from the word rotation, it means motion about an axis. That is what we call rotational motion. Example is like your ceiling fan. Do you understand? You can see the way your ceiling fan is rolling. So it's moving about an axis. Another one is oscillatory motion. Oscillatory, when you say something is oscillatory, from the word oscillate, that means it is a to and fro motion about a fixed point. We call it a to and fro motion. It will be moving from one point to another, to and fro. Example is like a pendulum. Have you seen a pendulum before? A pendulum is, you know, if you have seen the pendulum clock before, you know it will be removed. It will what? It will just be moving to, fro, like left, right. That's the way it is moving. That's all called oscillatory motion. Then the last one is random motion. From the word random, that means it's moving in an irregular manner. When an object is moving in an irregular manner or unpredictable manner, you can say that is a random motion. Example is a gas molecule. Gas molecule does not move in a regular manner. They move in an irregular manner. When you know it is moving in an irregular manner, you say it is random motion. Now let's move on to the three equations of motion. We have three equations of motion. The first one is, as you can see, is V equals to U plus AT. V equals to U plus AT. So as a physics student, you have to know this formula, because you are going to need it. The second formula is S equals to UT plus half AT square. S equals to UT plus half AT square. Whereas the third formula is equal to V square equals to U square plus 2AS. V square equals to U square plus 2AS. U is the initial velocity. In motion, we call U initial velocity, and V is called final velocity. Your A is called acceleration. T is called time. S is called displacement. So those are the three equations of motion you need to know. Do you understand? So you need to know all these three equations of motion. You are going to need it in motion as a physics student. Now let's look at this example. It says a car starts from rest. A car starts from rest and accelerates uniformly at 2 meters per second square for 5 seconds. Find A, its final velocity, B, distance. Now let's talk about A. Now, what are the parameters we are given? It says a car starts from rest and accelerates uniformly at 2 meters per second square. That is what? Acceleration, right? Equals to 2 meters per second square, right? Then for 5 seconds, time equals to 5 seconds, right? Now, find its final velocity. They say it starts from rest. That means your initial velocity will be 0 because it's starting from rest. Do you understand? When they say something starts from rest, that means you say the initial velocity of that object is 0. Take note of that. Now you are asked to find the final velocity, which is what? V, right? And we are asked to find what? Distance, which is S, right? So unknown, right? So now, what is the formula for V, velocity, final velocity? That is what? V equals to what? U plus what? AT, right? U plus AT. Now, what is our U? Our U equals to 0, right? Plus, what is our A? A equals to 2 times, what is our T? What is 5? Now, which will now be what? 0 plus 2 times 5 is what? 10. So that will be what? 10. What is the unit of velocity? The unit of velocity is what? Meter per seconds. That is it. So the final velocity is what? 10 meter per second. This is not magical. This is called meter per seconds. Meter per seconds. So that is the answer. Now for the second question, which is distance. S equals to, what is our formula? UT plus half AT square, right? So now, which will now be what? What is our U? 0 times, what is our T? What is our T? T is what? 5, right? Plus half times, what is our A? 2 times, what is our T? T is 5. Don't forget, it is T square, not ordinary t square, so 5 square. 0 times 5 is what? 0, plus that'll be half times 2 times 25, right? So which will now be 0 plus 2 here will cancel 2 here, that will be 25, right? Am I right? So which will now be what? 0 plus 25 will give you what? 25 meter. So that is it. That's the answer. It's very simple. Look at this question. It says a bike moves with uniform speed of 15 meters per second. How long will it take to cover 300 meters? So now they said you have given the bike moves with uniform speed of what? 15 meters per second. That means your speed, which can be speed, equals to what? 15 meters per second, right? Then how long will it take? They said time, calculate the time, how long it will take. You understand? And they're giving you distance to be what? Distance to be 300 meters, right? Don't forget, in physics, speed is equal to what? Distance over what? Distance over what? Time. Do you understand? Now you have to calculate your time, right? So what is your speed? 15 equals to distance 300 over time. That will be t, because you have to calculate time. So make cross multiply. That will be 15 t, right? 15 times t, 15t, 300 times 1, that's 300, right? So which will now be, you divide both side, divide both side by 15, right? So that means t will now be what? 300 divided by 15, right? So 300 divided by 15 will give you what? 20 seconds. So that's the time covered in 30 meters. So that is it. How long will it take? That is time. And now we have come to the end of the class. If this video has really helped you, don't forget to like this video, subscribe for more physics tutorials, and comment if you want me to explain any topic you find difficult. See you in my next video. Bye bye.